All right, we're ready to get started, everybody. Thanks for coming. Happy to be here. We're going to talk about AI software engineering today. Disclaimer, this is, as you probably got a hint from today's talks, an extremely fast-moving area. I drafted this deck on Thursday. There's been 4 major product releases, so every night at the event I'm going home and I'm working on my slides, and that's how this is going. But before we dive into it, even before I get to my intro, I just wanted to do a quick show of hands. How many of you have 100% of your engineers using an AI-forward IDE like Cursor? Okay, so about half the room, that's good. What about how many of you are using a low-code platform to use prototypes to communicate versus product requirements docs or user stories or something like that? Nobody. Okay, who's using, a little bit from Albert. Who's using a low-code platform to build internal tools and replace IT SaaS type applications? Okay, actually slightly more. That's interesting. That's inverted from what I thought. And then finally, who is using or has experimented with the AI software engineers?
Like Devin?
Yeah, like the Devin category of tools, and we'll talk about categories in a second. So a few. Okay, cool. All right. Well, I just wanted to calibrate. There's a wide distribution of where companies are at, and I want to try to hit the middle here. So with that, I'm Eric Johnson. I'm a KV operating partner. Formerly, I was CTO at GitLab, a fellow KV portfolio company. I was also on the board of the Linux Foundation for a couple of years, so I've got a strong open source background, and I've worked in other things prior to dev tools like drones and streaming video and localization tools and marketing technology and things like that. My role, I mostly work with our existing portfolio companies. I help with hiring. I may have helped some of you. I do advising, whether it's launch readiness or scaling advice or mentorship. And then I help out our investment teams due diligence if it's a domain I'm familiar with, and Vinod has me looking at all the AI code gen tools to inform our internal opinions, and that's a lot of what I'm going to share with you today. So the agenda is, first let's cover the step change that's happening in DevSecOps. I'm going to give you my mental model for the categories. Things are changing rapidly, but I think the categories are mostly the same, even if tools are sort of merging. I'll give you some examples, and then I'm going to try to make this really actionable for you. So I'm going to make some specific recommendations. I normally say stuff you could do tomorrow, but since you're KV portfolio, it's stuff you'll do tonight, right? And then we can speculate about the future a little bit and hopefully get into a nice Q&A. So this is the step change that's happening. On the left-hand side is the DevSecOps lifecycle, this figure 8 you're probably all familiar with, coming from GitLab. This was deeply embedded in our company. The stages of the DevSecOps lifecycle, like create and verify, those were the names of departments within engineering. Individual engineers had those in their titles. But there's a lot of complexity here. It's slow. It's oligarchic. Developers kind of rule the roost. What we're shifting towards is a model on the right where you're going from intent directly into AI and then into production. Now, all of the things on the left are what Scott this morning called kind of like irreducible complexity or essential complexity. They're still going to happen, but you're going to start to be able to take those things for granted, which is exciting. And then things are going to get faster. I think things are going to get simpler for the people with intent, and technology is going to be more democratized, which is a net good. So some terminology or some use cases. We'll talk about prototyping, and by that I mean, PMs and designers creating prototypes as opposed to product requirements doc and using those to hand those off to engineers and be a little bit tighter around communication. But also these could be landing pages you put in front of prospects, demos to customers, or so-called vibe coding projects. And then there's internal applications. So think of all the SaaS applications you use to run your business, or dashboards you might build, small CRUD apps, some internal automation, internal documentation, forms and surveys you might send to customers, but these are things that are outside of your product. And then lastly, there's product development, so bugs, features, and maintenance. Let's include some AI in there, so model ops, tests, and evals, refactoring work that you're going to do, and then integrating with other SaaS applications. But those are the 3 main use cases: prototypes, internal apps, and product development. And that leads us to categories. So the 3 categories that are emerged are there's low-code platforms, there's AI-forward IDEs, I've got some examples here, and then there's AI software engineers. And there's some overlap between the two. There's a bunch of different ways we could evaluate these, like, well, how good are their integrations, or how good is the user experience, or something like that. But I don't think that actually is what's driving these 3 categories. So this is my mental model. These 3 axes are what's making these 3 things emerge at this time. So on the y-axis, you have iteration, and it's from a scale of I'm building something 0 to 1, or I'm iterating from 1 to n. The sort of x-axis out there is infrastructure. Are you doing something simple and standardized, or are you doing something that requires custom infrastructure, getting closer to the metal? Most products are like that. To do something differentiated, you usually have to get a little bit closer to the metal. Things that are more standardized, more simple CRUD apps can get by with less optimized, simpler infrastructure. And then the z-axis pointing out here, I've got labeled asynchronicity. So this is on a scale from 1 to 1 with a human. The AI is interacting with a human. Everything needs to be, the classic UX threshold is 200 milliseconds. Obviously, large language models take a little bit longer than that, but we're fairly patient. But humans are in the loop here. And that goes out to a spectrum of things are now taking minutes, hours, days, weeks, maybe even months, years from now. And that's fundamentally different. I wish this axis said autonomy, but we're not there yet. So if you take asynchronicity and you add results, you get autonomy, but we don't have that yet. So I'm going to call it asynchronicity. And here's some examples. I've been evaluating as many as I can. I've got kind of a standardized script that I go through. Here's my evaluation procedure. And it gets sort of progressively more difficult and turns into more of a full-featured app. So give me a map-like interface. So usually integrate something like Mapbox. Generate points of interest on the map when I scroll around or when I search. Add a UI element on the front end to allow me to filter by category of the points of interest. Add AI-generated descriptions to the point of interest when I hover over it. So that calls out to OpenAI's APIs usually. And then a little bit more back-end, like add some authentication and then persist some data. Allow me to set favorites. And now you've got basically a full-stack app. So this first category, the low-code platforms, these are SaaS tools. They run in your web browser, and they usually have a cloud backend. These are intent-based, so it's humans working with AI. Most users aren't going to see the code. You kind of only have to interact with it when it gets stuck, and you have to unblock it if you have the skills. And the use cases here are the prototyping use case and internal apps. So Replit is a fellow portfolio company. They've got real-time multiplayer, so simultaneous collaboration. They've got a robust backend for your apps. I think they have a head start there because they've been going 8 or 9 years at this point, which is great. The team has really high product velocity, and one of the product launches that just happened on Friday after I drafted the deck was they've started down this enterprise roadmap and they've launched secure vibe coding, which means anything my team might create, it's not just going to be published out there on the web. It's going to have my whatever Okta authentication wrapped around it, and that's not dependent on AI. That's in the container, which enterprises need to make good business decisions. Next is Bolt. I think at this point, I haven't seen a lot of differentiators here. It has a large portion of market share. It was private by design, but that's not necessarily the same thing as saying it's enterprise ready in terms of data privacy and billing and all those other sorts of things. I found it to be honestly a little bit more buggy than competitors and get stuck. Although, keep your eye on the leaderboards, these things keep one-upping each other, so it's evolving fast. But as you can see, fairly similar results. So a lot of the power of these is coming from the foundational model. And then there's Lovable. I think you'll probably hear about this one from your internal teams. Their slant is they kind of cater towards PMs and designers. So their branding, their website, their tool is a more beautiful user interface, and it's appealing to sort of a segment of technologists. But also their output is meant to be more kind of designy, for lack of a better term. When I say give me a map-like interface, it usually responds, sure, I'll create a beautiful Apple-like interface for you. And it's like, well, I didn't ask for that, but great. So clearly there's some fine-tuning going on and probably some prompt injection that makes it more focused on designers. But they have some, thinking of designers, especially as their ICP, they do have some specific features for them, like upload, connect to Figma, upload a Figma file, and create my app off of this thing, which is a convenience. And then there's a bunch of other ones. So there's, as of Thursday, OpenAI's Codex CLI was here. We'll talk about that one more later. There's also AppSmith. This one's open source. That's the A logo on the upper right. There's V0, which if you're in the JavaScript, TypeScript ecosystem, if you're using Vercel, that's a nice one. And then there's DataButton, which is kind of a small upstart, but got started, I think, in 2023, pretty early. And that was the first one I saw that as sort of like task breakdown model of, I'm working on something that's reasonably complicated. I want to know how is it doing with these specific requests, and it's not just in one big linear chat. But that's not really differentiated at this point. It wasn't defensible. Lots of people are going down that road, as you'll see in a moment. Next is the roadmap for these tools. So they've got to integrate with more external services. They need to adopt this enterprise security model that we talked about, permissions, login, that sort of thing, ACLs maybe. They need to improve their ability to iterate 1 to n. It's very much 0 to 1 iteration right now. And then you could adopt, multimodal ways of expressing your intent, like voice and image upload and things like that. So I think you're going to see that in the next 6 months. A lot of these features appear. Next is the AI-forward IDEs. So a different model than the low-code platforms. This is about local development. So it's very much taking the way humans develop software today, your teams, and augmenting them with AI as efficiently as possible. So these are downloaded and run on the developer's computer in their development environment in most cases. This is human first, so humans augmented by AI rather than the inverse. And the use cases are usually product development here. So you could do a prototype here, but these tools are a little bit overpowered for that. You might use something low code for that instead. So it's really product development, human first, slots very nicely into your current workflows. So there's minimal switching costs for these tools. So there's Cursor, first mover thanks to Andre Karpathy's tweet. He's a tastemaker, best in class on AI coding with humans, user experience certainly. And for better or worse, it's fashionable, it's attractive to the extent you're fighting the adoption battle. I think Cursor has the sort of, the least amount of resistance from engineers looking to switch from Emacs or whatever it might be to try something new. Next is Codium's Windsurf. At this point, I think we're splitting hairs. This one I favor slightly over Cursor, but honestly, I would say that's just a me difference, not like a quality difference. If you're deciding between these two things, I would say whichever one your team wants, go with it, and you're getting about the same sort of results. I found it to be personally less buggy. That's one of the things I appreciate about it. It does feel like they are a little bit more enterprisey. So to the extent I'm a engineering leader, an IT leader, and I'm buying a site license and a bunch of different seats, they seem a little bit more built to handle those sorts of things. And then here's kind of like a dark horse, so Z Industries. This is from the team that created the Atom IDE at GitHub years ago. This is one of the few IDEs right now that's not built on top of VS Code. So this is a ground-up new application. It's Rust-based, and when I say the performance is insane, I mean milliseconds, they do not go by that. They measure in frame rate. So this thing renders at like 80 to 120 frames per second, like a video game does. So it's a pretty, if you're into that sort of thing, keystrokes, it's a pretty fun experience. It's really fun to code in. It has natural inroads into the Rust ecosystem if you're doing any kind of embedded software. It is open source too, so near and dear to my heart. It is honestly, because they were going performance and these other sort of developer communities, they're now a fast follower with the UI experience, but I think they'll get caught up quick. And then there's some other ones. Pair is another sort of VS Code extension coming out of YC. Here's VS Code itself. Most people pair it with Copilot or Anthropic's models. IntelliJ is still here for Java, or especially our Android friends doing Kotlin. They're adding similar features. And then I always feel for iOS developer friends, they have some rough tools. But now Swift Assist is finally in Xcode after a long delay. And so I hope they're having a better time there. But people are generally chasing the same model here from Cursor. And then the near-term roadmap, they've got to maintain that fast front-end performance. It's not just a nice-to-have. Again, it's one-to-one relationship between AI and humans. So they have to maintain that even as they add more complex features. They need to add the ability to make larger, more sweeping code changes over your code base. So larger context window, smarter RAG, those sorts of things to improve the quality and scale of the suggestions that they make. And then I think they've got a strategic decision, which we'll talk about more, but do they actually start to pivot and move towards the next model? We'll talk about the AI software engineer. We're already seeing announcements that indicates that they're doing so. So long term, I'm unsure what the end state is for AI IDEs. As much as we're saying adopt these now, yes, that's true, but talking 5 years out, things could change pretty radically. And then similar to low-code tools, they should be adopting vision and voice and multimodal sort of intent expression. And so now, finally, we get to the AI software engineers. So these are SaaS. You have n number of these agents working off of your backlog and your code asynchronously, and that's the key. And this is subtle but important. It's inverted. It's AI first, helped out by a human. So we're decoupling that one-to-one relationship. And when these things really work, what could you do with 500 or 1,000 or 10,000 of these working if they're having an impact, right? That's really powerful. So the use cases here, it's very similar to what you would do with an AI IDE, but in terms of the level of autonomy they have, in practice, they're pretty good at reviewing your code as a CI job, and they can handle kind of low complexity changes. Now, when I first had this insight, I thought, oh, well, that's my P4 backlog. What's really the business value in doing that? And I was corrected by someone starting to say, no, it's not low priority, it's low complexity. That 70-line code change might be a 0-day vulnerability that it's solving, which would be like a P0 issue, right? But it's low complexity issues, so junior software engineer stuff. But getting better very rapidly, and I think close to the takeoff point. So Devon, or Cognition's AI, Devon, I should say, another portfolio company, is kind of the first mover here. They made a big splash when they kind of had a step change improvement in the SweBench benchmark. They're designing a product that's an AI software engineer for the enterprise first. But when you look at this UI, it's hard probably for you to distinguish between this and an AI IDE, right? So there's also SWE agent. So the SweBench team has their own SWE agent out there. It's honestly a research tool. I think you could probably build something with this, but I don't think you need to based on the other options available. It's headless. There's no infrastructure for it. You can run it. It mostly works, but it would be kind of like a tool in a toolbox. And you're self-hosting it. And then there's OpenAI Codex. So this is one of the major product releases. On Friday, they took Codex from a CLI, and they built a UI around it, and now it's available for ChatGPT Pro accounts for $200 a month. I'm seeing best-in-class results. I think more importantly, look at this UI. It's not just cleaner, simpler, beautiful compared to the relatively noisy IDE-style ones, but this is a supervisory IDE. This is a UI that's meant for you to command n number of these things, and that's a fundamental sort of difference. So we're already seeing things shift, even with the AI software engineers. And then this squid here, get used to seeing this. Yesterday, Google announced Jules. They've chosen a purple squid for their logo, so kind of similar to GitHub. But I expect big things from them. But we'll see. It may be very tightly coupled to Google Cloud Platform, and in which case, if you're using other infrastructure, using other tools, maybe it's less relevant. I'm on the wait list, like many of you are, so I'm going to kick the tires on it as soon as I possibly can. But I'm hoping for maybe parity with OpenAI's Codex. We'll see. And then there's Factory. That's another VC-funded startup that's similarly building asynchronous software engineers. I haven't been hands-on with that one yet, but it feels very Cognition-like, I would say, from the marketing materials I've read and the videos I've seen and whatnot. So that near-term roadmap, they've got to support a broader array of environments, different languages, different DevOps choices. Again, you're plugging into existing workflows here, and so people have microservices. They've got mono repos. Needs to understand all that to be effective. You also have to incorporate, if you think of replacing a human software engineer eventually, think of all the data humans take in to make decisions as a software engineer. There's observability, logs, metrics, and traces, and then more business data. So BI data, business goals, KPIs, things like that. So specific recommendations for CEOs, things hopefully you can do this evening. I think this should be your ambition level. This is the distribution of things I hear from companies in our portfolio, not. Some say we're blocked by legal. I think legal should inform you of your risks, but you should make the decision as a CEO. Don't be blocked. I think most people say, well, most of our engineers are using it. And then some people are way out on this right tail saying, we're no longer hire humans. We're only investing in AI, even if it doesn't work yet as well as we want, and even if it's more expensive. We just trust it's going to be there. I want you to be at least a standard deviation better than the normal. So that's what I would challenge you to do. And I think this is what this looks like. So one, when you're hiring, I think you should make your tech evals more difficult for humans. Not necessarily in terms of difficulty, but you should expect them to accomplish more in that same 60-minute time block. And they should bring their AI IDE of choice and show you how they code using it and how productive they can be. For your existing team and the people that you add, you need to start to manage performance. I don't think you should say to people, you now have to use this, but I think you can say, we have new higher productivity standards, and it should be obvious that the only way to meet these standards is to use these tools. And I think that's how you drive adoption, is to be results focused, not to tell a developer what tool they should be using. And then with headcount planning, I'd argue, don't add excessive headcount before you feel like you're fully leveraging all of these AI tools, because you could get a lot more short-term leverage out of them by investing here before you add a bunch of people. Next, obviously, I think everybody's here, but like have a chat account for every employee. It's for learning, it's for productivity. It could be a coach or even a mentor, but buy the enterprise account, protect your data, have your lawyers review the contract, protect your proprietary information, your customers' information. Don't let people do it kind of in their own personal accounts. And buy a site license for those AI IDEs. If you can get a reach degree, I would say if 75% want to use the same thing, Cursor, Windsurf, just buy it for everybody and give it to every new employee when they start so they have it. Next, use a low-code platform for that PM designer handoff for internal ideation. There's a lot of time lost from information being obscure or slipping through the cracks. And then also use that low-code tool to automate some internal workflows. I talked to a large public company that created a small app over the weekend, and they value it internally at $10 million. And they have numbers to back that up. And they're obviously at scale, but this is outside of your product. There's a lot of things going on in your company today that are manual that could be done a lot faster with software. And then start experimenting with AI software engineers. Let it review your code as a CI job. Let it start to solve low complexity issues in your backlog. You'll probably hit some stumbling blocks, but I think the takeoff point is very soon, and I think it's going to be a very steep curve, and I don't think you want to be waiting at that point to invest in. I think you should start to experiment with high confidence right now. And then try to push back against over-reliance on these tools. People get into vibe coding and start tabbing through suggestions. If you have existing quality or security issues, I think this could exacerbate it. So be mindful of that. Make sure you've got your head of engineering, your VP of engineering as the qualities are, putting the right checks in place to make sure that people aren't just vibe coding their way right to production now at high volume. And now let's speculate about the future a little bit. So I'm thinking like from the 5 to 10 year time frame. Foundational models are obviously going to get a lot smarter. I think that allows the IDEs and the software engineers to kind of shift left and start to get better at 0 to 1 creation of these complex infrastructure environments versus today they're plugging into your existing stuff. Then I think the low-code tools start to become better at 1 to n iteration, and you can take those internal apps that you're creating much further and live with them for hopefully years. I think the prototyping use case for low-code tools probably gets commoditized. I think all of these tools will be able to do it. You could probably even do it in your chat. So I think you'll see a lot of low-code tools pivot towards internal apps as a use case. And I also think like the nature of software is changing. So we can talk about how AI could help create yesterday's software, but in 5 years, AI itself is going to replace a lot of what we call software today. So you kind of have to skate towards the puck and think about how is inference going to be happening in production as well. And then some response times are going to increase dramatically, and that's okay because they're going to be worth it. But that asynchronicity is going to heavily favor the AI software engineer model over humans with IDEs. And so as much as I'm pushing to adopt IDEs now, I think there's another step change happening at some point after. And breaking that 1-to-1 ratio between humans and AI is going to unlock a vast amount of productivity for just the cost of compute. Hundreds, thousands of software engineers working on your product, which is incredibly powerful. And then code gen reaches a tipping point. I think maybe in this time frame, software engineers become as rare as bumping into a chip engineer on the street in San Francisco. There's orders of magnitude fewer of them than software engineers today. That might happen. I think bittersweet, but the open source ecosystem might be negatively impacted. I think it changes the idea of just spinning up an application with intent, changes the incentive structure on open source. You'd be less apt to contribute to and use open source code. However, the transparency use case for open source, that remains. I think you'll see companies open sourcing their code just so people can read it. Like if you're installing MDM software on someone's computer and employees get paranoid about that type of thing, if they can go read the source code, I think they're going to be happy with that, even if there isn't a virtuous cycle of use and contribution there. And then I think we're going to see a narrowing of languages and components. I think a lot of these things, we've had an explosion of languages and especially data stores over the past 10 years. I think a lot of these things are about our cognitive limits as humans. A lot of it is just fashionable. I think when AI is doing most of the work, things might narrow down to a smaller set of languages and tools. And that will be fine, because it's about the end result. And then software engineers are going to incorporate the much more DevOps lifecycle data. So logs, metrics, traces, and BI data and business goals. And that's going to allow AI software engineers to propose backlog issues, not just complete them. Autonomously, optimize and heal systems kind of on their own. And then I think the economics and scalability of AI software engineers radically outweighs IDEs. So what does that look like? I'll go back to my isometric diagram here. I think the AI IDE is gone. AI itself is there in its place doing a lot of these different things. So there's low code there. There's still AI software engineers, and they've kind of matured into different phases of iteration, but are still doing kind of product and non-product things. And this is what's going to be driving the categories at that time. And again, I've changed the asynchronicity axis here to autonomy because I think we have this at that point, and it can be relied on. So that's everything that I prepared. When I get to questions, or if people don't have questions, I'm happy if someone just stands up and shares like a story of trying out these things, or something that went well, something went poorly. We're all going to learn from this. I think we've got a microphone in the back for questions. Just state your question loudly and clearly so the rest of them can hear it.
All right. How long before we have a system where it's like a SaaS product, I connect it to my Git repos, a big RAG distillations built of all of my repos, and I can go and have some kind of chat where I'm like, hey, I need to extend a feature or build a service, and then it basically populates Jira with the tasks. I approve all of them in Jira, and another system comes out, reads the tickets, and then using RAG and understanding of Git, either builds new repos or modifies other ones, and deploys it out, ready to go, merge, ready for prod. Like, what about the full real life cycle, not just an SWE, but like the whole thinking on it. So someone that's managing a software engineering team can give 5 human engineers tasks and then literally assign tickets that are generated by AI for something else.
Yeah, I mean, I think I'm on record saying that's in the 5-year time frame. I think the underpinnings of that arrived literally this weekend. And so like individual issues would make it through that loop now. The capability, the quality isn't quite there yet for everything to make it through, but I think we're well past that 80% tipping point when we're talking 5 years out, probably a lot sooner than that.
I was going to say, everything I just said, that's tech someone can do, right? Like what makes it not 5 months? I mean, there's no tech that needs to be invented to just build the loop I just said, right?
Well, I think, again, the right half of that DevSecOps diagram that I posted up there is not really in the loop on the system yet. So that has to be wired up. The current AI models haven't proven that they can analyze logs in large batches and develop insights from that, but I think that's coming pretty soon. So we're going to see that stuff arrive over the next 18 months. And the foundational models, I do think, need to get smarter. They need to be a little bit more reliable, and then I think we have that. And then we're arguing over like 1 or 2 years.
Oh, yeah. Time frame. Well, thank you for distilling all of this, by the way. It's enormously helpful.
Sure.
So I was going to ask that, but I have 2, so that's good. I can only ask 1. So on the prototyping side of things, I've been mentally somewhat resistant to doing that for a couple reasons. One is that it seems like all the tools are completely decoupled from then the tools that my devs are going to use. So it just feels like, am I really accomplishing anything, in terms of productivity? I mean, I might have a higher fidelity design, and that has communication benefits, but I'm not sure that it's better. And then, I don't know, this might be the oldest guy reference ever, but I still think about the old good product manager, bad product manager, and the one line that sticks with me from that is bad product manager thinks they're part of the engineering team.
Yeah.
And this really makes me think that this is going to exacerbate that. And like for me, product management is a marketing function more than any other thing, right? Understanding customers. And so any thoughts on both the flow of like Replit to, even today, Replit to cognition doesn't really work, and so I'm creating 2 separate workflows, and then just the broader thing of like, are all PMs becoming devs? And I don't really want that, I don't think.
That's why I think the end state for the time horizon I can see to 5 years is, you have your product, and that's where you're going to use AI software engineers. To the extent you're talking about features, you're probably doing like prototyping in that tool with that AI, and then we have internal applications, and that's going to be a low-code platform, and you'll be prototyping ideas there. But that's separate from your product. But they'll both be probably equally capable of prototyping. But if you have a whole whatever the tool is, and a batch of AI software engineers integrated into your tool, why would you prototype features outside of that system when it's just the same prompt? So, and then all this stuff is a force multiplier. So the extent you have organizational issues or people overstepping bounds or whatever, yes, it could amplify all of that stuff, not just quality and security issues. But you could still, in this world, lose focus on your customers. And these tools would allow your, if it was possible for your product or platform to diverge from what your customers wanted in the old world, in this world, you'd go even further apart faster. So you still have to be very mindful of that.
Just one small thing is, are you really saying that the no-code stuff is really more for internal then, and so there's not really the idea of having PMs or designers step in as the first function and pass that over inside of a devlin or whatever? Or
no, I think anybody should be able to express their intent. I just think you probably have one system for your product because it has very deep specialized infrastructure needs, and that's where they would be expressing their ideas. So the PMs would be actually working in the AI software engineer, but it doesn't mean that they're shipping ideas to production. You should govern that with permissions. So.
Thanks.
Okay. Thanks for the overview. I wanted to talk a little bit more about the recruiting a headcount planning, because our number one challenge so far has been recruiting like really good engineers, and now maybe I shouldn't recruit them anymore. And it also seems that 5 years is too long, since the most is you look at when you're going to break even or the next round of financing. It's usually 12 to 18 months away. I think that's the right time frame from my vantage point. And if I think 12 to 18 months away, I mean, like, should we hire? Should we not hire? If we hire, should we hire higher quality bar engineers? Because I've used these IDE things, and it can't, like, bad choices and a lot of infra stuff, and I don't know if a medium level engineer is going to see it, but now you're recruiting CTO types, which are really expensive, but then someday the AI can do the CTO job. Now you've over-provisioned. I don't know, how do you, what is your mental model on all of this?
So good questions, a lot of stuff going on in there. I would echo Vinod and say, like, your company, the people you hire is the company that you're designing, so always hire great people. The most leverage you get today is out of a human assisted by AI in an IDE. And then there's a gradient from now to 2-5 years out where you're going to see things flip. I think you can start to use AI software engineers now, but as a junior engineer on your team. And I would say, leverage everything you can about AI, and then what your productivity is, almost kind of on a unit basis. And then you have your business opportunity, which you just have a thesis about. That should dictate your product roadmap, and then the product roadmap should dictate your team. And now you're hiring people who will be using AI to be as maximally productive as they can. And those people, again, you should interview against their ability to be productive with AI.
I was going to ask a follow-up question. It just came to my mind that the people normally closest to the customers a lot of times, CSM team, historically low value because they can't code, but now all of a sudden, like, is that something you guys are thinking about?
Yeah, so the question was, what about like your customer success team? So yeah, they certainly, that information should today be feeding through your product management org and be getting into the product. That should stay the same. I think the low-code tools have the potential to allow them to automate some software without burdening the engineering team, automate some of their workflows, and that can be, can lower operational costs, and you can get some leverage out of that as well.
So how differently, if at all, should we be thinking about applying these tools in like a research context? So a lot of the work we do is around developing novel models and training algorithms for physical problems, so problems in the physical sciences. So a lot of the use cases and examples I've heard today and other times have been around implementing features and prototyping features for active products, whereas we have a significant portion of our work is still in the applied R&D phase and development in that side. So yeah, I guess how would you recommend best leveraging these tool sets for those types of problems?
Yeah, good question. I would say to the extent that your research involves code and algorithms, definitely use the AI IDEs. And to the extent that that code is not being exposed to customers and maybe it only needs to run once, then to the extent we're dealing with some quality issues, some capability issues, you're less prone to those because that you don't have the sort of like enterprise grade production standards on that type of code.
So we are using the IDEs now, which have been great. Really, really a fan of them. I'm just wondering if there's applications for the no-code stuff or anything else that, because of that freedom we have, that we should also be thinking about beyond the IDEs.
Yeah, I mean, we could take it offline. It kind of depends on the line of research that you're in. If you're communicating visual ideas, I could see the low code being applicable. If you are working in one repo and that infrastructure is fairly standard, then I could see it's worth the effort to wire up some AI software engineers to operate in that repo as well.
Cool, thanks.
Okay, it looks like we are at time. So do me a favor, we've got to turn over this entire room and open it up for the next talk. So let's get our things and walk outside. I'll be on the balcony if anyone has more questions and want to iterate on this stuff more. But thanks for coming. Cheers.